All right, so you think you know C Sharp, huh? Well, today we're going deep, like really deep into the heart of C Sharp to uncover some of its hidden secrets.
That's right. We're diving into the world of lowered C# code.
Lowered C Sharp code, what's that all about?
Well, think of it like this. You write your nice, clean C# code, and then the compiler comes along and it's like, hold my beer. It takes your code and transforms it into something the .NET runtime can actually digest.
So, what we write isn't exactly what the computer sees.
Exactly. It's a little bit like translation. We're speaking C#, but the computer speaks a different language. The compiler is the interpreter, making sure everyone understands each other.
Okay, I'm starting to get the picture, but why should we even care about this lowered code? I mean, we're not writing it directly, right?
True, but understanding this process, peeking under the hood, can make you a way better C# developer.
Yeah.
You start to see the why behind the what, and that can lead to more efficient, more robust code.
Gotcha. So, what kind of C Sharp features are we talking about here? What gets lowered by the compiler?
Oh, lots of things. But today, we're going to focus on three big ones: for each loops, using statements, and the magical world of async.
Ooh, those are some heavy hitters. I use those all the time.
Exactly. And by the end of this deep dive, you'll see them in a whole new light. Not just as convenient shortcuts, but as powerful tools built on some pretty clever underlying mechanisms.
I'm ready to be enlightened. Let's start with for each loops. You use those all the time, right? I mean, they're so simple and elegant, just loop through a collection without messing around with indexes. But have you ever wondered what's happening behind the scenes?
Oh, there's a lot more going on than meets the eye. Behind the scenes, the compiler takes that for each loop and transforms it into a while loop using something called an enumerator.
An enumerator. That sounds intriguing. What exactly is that?
Okay, so imagine you walk into a library and ask for all the books on C#. Right. The librarian, in this case, is our enumerator. They go through the shelves, which is like our collection, and they bring you each book, each element one by one.
I see. So the enumerator is like our personal C Sharp librarian fetching each book in order.
That's a great way to think about it. But here's where it gets even cooler. If you were to actually look at the lowered code that the compiler generates, you'd see these two important methods: move next and dispose.
Move next and dispose. What are those all about?
Move next is what tells the enumerator, hey, grab the next item in the collection. It's like the librarian saying, okay, here's the next C# book for you.
Got it. So move next keeps the books coming. But what about dispose? What's its role in all of this?
Dispose is all about cleanup, like a good librarian putting the books back on the shelf neatly when you're finished. In code, it releases any resources the enumerator was using.
Resources. Like what kind of resources?
Memory. Remember, every time you create an object in C#, it takes up some memory. The enumerator needs some memory to do its job.
Ah, that makes sense. So if we don't dispose of the enumerator properly, we could end up with a memory leak.
Exactly. And memory leaks, those are like little gremlins that can slow down your application over time. They're not good.
Yikes. So even though we write these nice, clean for each loops, there's a whole lot going on behind the scenes to manage resources and make sure everything runs smoothly.
That's C# for you.
Mm.
Elegant on the surface, but with some serious power and sophistication working under the hood. And knowing this, understanding how the compiler is handling those resources, can really help you write more efficient and reliable code. Especially when you're dealing with, like, massive collections of data.
So it's like we're not just writing code, we're working in partnership with the compiler.
That's a great way to put it.
Okay, I'm definitely starting to see the value in understanding lowered C Sharp code. It's like getting a glimpse behind the curtain, seeing how the magic trick is done.
I like that analogy.
So now that we've demystified the for each loop, what's next on our agenda?
Let's talk about the using statement. Now, this one is all about keeping your code clean and tidy.
Oh, I'm all about clean code. But I've always been a bit fuzzy on exactly why we need using. I mean, what's the worst that could happen if I just create an object the regular way without using?
Well, imagine this. You open a file to read some data, right? But then you forget to close it properly. Without a using statement, that file could stay open indefinitely.
Even after my program has finished using it.
Yep. It's like leaving a faucet running constantly. You're wasting resources, and it could even cause problems for other parts of your system.
Yikes. So the using statement is like our insurance policy, making sure that those resources get closed no matter what.
Exactly. You see, behind the scenes, the using statement is actually transformed into a try finally block. The code that uses the resource goes in the try block, and the finally block guarantees that the resource's dispose method is called, even if an error occurs.
So it's using exception handling to manage resources. That's pretty clever.
Right. It's like a safety net. No matter what happens, those resources are going to get cleaned up properly. And that's a big part of writing robust and reliable C# code. Without using, you risk resource leaks.
Resource leaks? Those sound nasty. Are those like memory leaks?
They're similar, yeah. Resource leaks can be anything from open files to database connections to network sockets that aren't closed properly, and they can really slow down your application or even cause it to crash.
Okay, I'm definitely convinced using is not just a good practice, it's essential for writing code that's both efficient and reliable.
And that's really the key takeaway here. Understanding the lowered code, seeing how the using statement gets transformed, it gives you a deeper appreciation for how these seemingly simple features are actually working hard to keep your code clean and performant.
Now for the grand finale, async await. This one always feels a bit like magic to me. Writing asynchronous code that can run in the background without blocking everything else, and it looks just like regular synchronous code. How does C# pull off this incredible feat?
Sync-await is definitely a powerful tool. And yes, it does feel a bit like magic, but, like all magic, there's a lot of complex machinery working behind the scenes.
Oh, I bet. It's like one of those elaborate stage illusions, right? Lots of smoke and mirrors.
Yeah.
Kind of. We're talking about state machines, awaiters, builders, a whole symphony of components orchestrated by the compiler.
Whoa, that sounds intense. State machines. I'm already feeling a little lost.
Don't worry, it's not as daunting as it sounds. Think of it like, imagine a chef juggling multiple dishes at once. They're stirring one pot, they're chopping vegetables for another, and keeping an eye on something baking in the oven all at the same time. But they're doing it all seamlessly, without missing a beat.
Okay, I can picture that. So the chef is our code, and the different dishes represent the asynchronous tasks we're trying to manage. But where do the state machine, the awaiter, and the builder fit into this culinary masterpiece?
Well, the state machine is like the chef's mental checklist, keeping track of which dish is at what stage of preparation. The awaiter is like their sense of timing, knowing when to check on a particular dish to see if it's ready. And the builder is like the kitchen itself, providing all the tools and the environment for everything to happen seamlessly.
Okay, that analogy is really helpful. So we've got the state machine managing the flow of the operation, the awaiter checking if a task is complete, and the builder providing the framework for everything to run. But what does this actually look like in the lowered code?
When you use async await, the compiler takes your seemingly simple code and transforms it into this intricate state machine. It breaks down your asynchronous operation into smaller steps, and it manages the execution of those steps, pausing and resuming as needed, all while giving you the illusion of a single seamless flow.
Wow, so our elegant async await code is actually shorthand for a much more complex process. It's kind of mind-blowing.
It is, and while you don't need to understand every detail of how the state machine works, just knowing that it's there, working diligently behind the scenes, can help you write more efficient asynchronous code. You start to appreciate the power of async await and avoid some common pitfalls.
It's like being able to enjoy a delicious meal without having to worry about all the intricate steps involved in preparing it.
Right. But having a glimpse into the kitchen can definitely give you a deeper appreciation for the chef's skills. And in this case, the chef is the C# compiler.
And those skills are impressive.
Absolutely.
Well, this has been an eye-opening journey so far. We've peeked behind the curtain of some pretty fundamental C# features and discovered a whole world of complexity and ingenuity working beneath the surface. But we're just getting started. In our next segment, we'll explore some of the amazing tools that can help us visualize and even interact with this lowered code. So stay tuned for more deep diving.
Welcome back to our deep dive into lowered C# code. Before the break, we were talking about how even seemingly simple features like for loops, using statements, and async await involve some pretty complex stuff under the hood.
Yeah, and it's kind of mind-blowing to think that the compiler is doing all this heavy lifting behind the scenes, transforming our code into something the computer can actually understand.
It's like a secret code almost. We write in C#, and then the compiler translates it into this lower-level language that the .NET runtime can execute.
But it's one thing to talk about these transformations and another to actually see them. Are there tools that can help us peek into this hidden world?
Oh, absolutely. There are some amazing tools that can act like X-ray glasses for your code, letting you see exactly how the compiler is interpreting and transforming everything.
Okay, I'm intrigued. What are some of these tools that we can use to unveil the mysteries of lowered C# code?
One of the most powerful tools is called ILDASM, which stands for Intermediate Language Disassembler.
Whoa, disassembler. That sounds pretty hardcore. What exactly does it do?
It lets you see the intermediate language or IL code that the C# compiler generates. IL is a step closer to the machine code that the computer actually runs.
So it's like a bridge between our C# code and the language that the computer actually speaks?
Exactly. And by looking at the IL code, you can gain a deeper understanding of how your high-level C# constructs are being translated into lower-level instructions. It's like being able to read the blueprints of your code.
That sounds super insightful, but I have to admit I'm a little intimidated. Is ILDASM something that only, like, super experienced developers use?
Well, it does take a little getting used to. ILDASM presents the code in a more assembly-like format, but it's actually more readable than you might think. And with a little practice, you can start to recognize the patterns.
So it's not totally out of reach, even for someone who's not a low-level coding guru. But are there other tools that might be a little more, shall we say, beginner-friendly?
Sure, there are some great tools out there that can help you visualize these transformations in a more graphical way. Have you ever heard of syntax trees?
Syntax trees, I think so, but remind me.
Imagine a diagram that breaks down your code into its individual parts, kind of like a family tree. It shows you how the compiler sees your code, how it groups things together.
Oh, okay, I'm starting to see the picture. So it's like a visual representation of how the compiler parses our code.
Exactly. And there are tools, like Roslyn Quoter, that can generate these syntax trees for you.
Roslyn quoter, I'll have to check that out. That sounds really helpful, especially for someone like me who's a bit more of a visual learner.
It is. And the cool thing is you can actually use Roslyn-based tools to analyze your code in real time as you're writing it. So you can see those syntax trees evolving as you make changes.
Wow, that's amazing. It's like having the compiler looking over your shoulder, giving you instant feedback on how it's understanding your code.
It's pretty powerful stuff. But it doesn't stop there. Even Visual Studio itself has some really cool features that can help you see this lowered code in action.
Oh, like what?
Well, have you ever used Just My Code debugging?
Just my code debugging. Yeah, I think I've seen that option in Visual Studio, but I've never really used it.
It's a really useful feature, especially when you're dealing with asynchronous code. It basically lets you step through your code during debugging, but it focuses on the code that you wrote. It filters out all the noise of the code that was generated by the compiler.
So I can actually walk through the lowered code, like line by line, as if I had written it myself.
Yep, pretty much. It's like watching your code execute in slow motion. And that can be really helpful for understanding what's going on behind the scenes and finding those pesky bugs.
Okay, I need to start using just my code debugging. That sounds like a game changer. But with all these tools at our disposal, where do we even begin? It's like having a toolbox full of specialized gadgets.
You don't need to use all of them all the time. Start with something like Roslyn Quoter to visualize the syntax trees. That's a great way to see how the compiler's interpreting your code. Then, when you're ready for a deeper dive, you can check out ILDASM and explore the IL code.
So it's kind of like a choose your own adventure for exploring lowered C# code.
Exactly. And don't forget about Just My Code debugging in Visual Studio. That's a really powerful way to see these transformations happening in real time.
All right, I'm definitely feeling inspired to go on a C# code spelunking expedition. But before I get too carried away, I want to come back to that question we posed earlier. Why should we even care about this lowered code if we're never going to write it directly?
That's a great question and one that we should explore further. So let's take a short break, and when we come back, we'll dive into the practical benefits of understanding lowered C# code and why it can make you a better developer.
All right, so we've spent this deep dive exploring lowered C# code, this hidden world where the compiler transforms our code into something the computer can actually understand.
We've talked about how foreach, using, and async await all involve some pretty complex transformations under the hood.
And we've even discovered tools that let us see those transformations in action. But now for the big question, why should we even care about this lowered code if we're never going to write it directly?
It's all about leveling up,
Oh, yeah.
going from a good C# developer to a truly great C# developer.
Okay, I like the sound of that. But how does understanding this lowered code actually help us write better code?
Well, take foreach loops, for example. Knowing that they use enumerators and that dispose method, it makes you more aware of potential performance bottlenecks,
Yeah.
especially when you're working with massive data sets.
So you're saying I might realize that a regular for loop could actually be more efficient in some cases.
Exactly. Or think about async await. When you understand the state machine behind it, it helps you structure your asynchronous code more efficiently. Avoid those common pitfalls.
It's like once you know the rules of the game, you can start playing it strategically.
That's a great way to put it. And then, of course, there's debugging. When you run into a tricky bug, understanding the lowered code can help you pinpoint the root cause.
Ah, so it's not just about writing code, it's about debugging it too.
Absolutely. It gives you this deeper insight, this X-ray vision into what's really happening.
I'm starting to see that. It's like we're not just writing code, we're collaborating with the compiler almost.
That's a great way to think about it. Understanding its nuances, speaking its language.
So it's like becoming bilingual in C sharp.
Exactly.
Hmm.
Fluent in both the high-level syntax and the lower level, the compiler's language.
Well, this has been an incredible journey. We've learned that there's so much more to C sharp than meets the eye.
It's like we've uncovered a whole hidden world, all these complex mechanisms working behind the scenes to make our code run smoothly.
And we've even learned about some powerful tools that can help us explore this hidden world.
So, to all you C-sharp enthusiasts out there, keep diving deep, keep experimenting, and keep pushing the boundaries of what you thought was possible. There's always more to learn.
And that's what makes software development so exciting, isn't it? Always more to explore, more to discover. Thanks for joining us on this deep dive into lowered C sharp code.